This meeting is being recorded.
I'll ask the participants to mute themselves as we go forward with the discussion and engage, make questions, put questions on the chat throughout the presentations. The session today will be divided in two parts. The first part, we are gonna have a roundtable talking about disruptive technologies, where we have three amazing speakers that will be talking to us and giving us examples. And then we are gonna have a Q&A for this session and go to the second portion of the training today, which will be a presentation from award winner project in Argentina, that innovation project. So we can also have another example of a competition that happened and how was implemented in nuclear and so on. So to start our first portion of today's sessions, I'm gonna introduce our first speaker. It's Nelly. She's a nuclear power engineer, instrumentation and control for the IAEA in the nuclear power engineering section. She's an instrumentation and control expert with 15 years of specialized in nuclear power industry with international collaborations, and has more than 20 years of global experience in projects such as design assessment, compliance analysis, obsolescence, LTO, hardware and software qualification, defense in depth, among many other things. So Nelly, thank you very much for accepting our invite, and the floor is yours.
Good morning, everybody. Alice, you can hear me? Okay, great. So I have prepared a few slides to talk about, I'm sorry, the initiative. We at the IAEA, we are working on, can you confirm that you can see my slides?
Yes.
Oh, great. Good. So at the IAEA, we started to work on artificial intelligence 2 years ago, I would say, and the initiative started to run faster since last year. So in 2021, the IAEA organized this big virtual technical meeting on artificial intelligence, focusing on all type of applications, methodology, tools using AI. And then the IAEA organized the participants in different working groups, and one of those working groups focused on nuclear power. So we issued a publication gathering all the aspects covered during this technical meeting, and it is available free of cost online. And then last year in July, we organized a consultancy meeting with the key members of this working group in order to identify where the IAEA could support the member states. So during this consultancy meeting, we talked about different aspects related to the use of AI, the challenges, the issues, the gaps, and then from the different discussions and observations, we defined 6 main recommendations that are used for, as the basis of our roadmap to develop AI activities in nuclear power. So those recommendations are listed on this slide, and they are relevant to several sections, and they are not fully independent. So I will talk about my activities. So I'm working in the nuclear power engineering section in the Department of Nuclear Energy, and I'm in charge of the first recommendation related to issuing a publication providing an overall guidance on the deployment of AI solutions in nuclear industry. And also in parallel, I'm working on trying to establish a state of the art, because AI is a trendy topic, and we have to define and to try to define how valuable it could be for nuclear power. So on this slide, you can see the other activities led by my colleagues from different sections. So the technology development section, for example, have established a collaborating center in collaboration with Purdue University in the US. And in parallel, my colleagues from the safety assessment sections are working on issues related to safety justification, safety demonstration, and all other regulatory aspects related to the use of AI in nuclear power. So we established this model last 2 months ago. So in April, we launched a new network. It is an IAEA network called the Innovation Network to Support Operating Plans. And we are focusing on these innovative technologies and the benefits we could get from them. So this we have a steering committee in this network. It is formed by people nominated by the member states, and then we have an external chair and a IAEA scientific secretary. And then we have members. So in the frame of this network, we have established different working group, and the pilot working group is the working group on artificial intelligence. It is formed with international stakeholders, and we have several scientific secretaries from different sections, and all the members of those of this working group are supporting us in the different activities. So for we have the first working group on AI that I'm leading, and then my colleague Aninda Dutare is leading the working group on advanced manufacturing. So we are considering several other topics like virtual reality, digital twins, etc. So those are the two first working group established. And as I said, we are trying to gather knowledgeable stakeholders. So we focus on nuclear utilities, nuclear regulators, AI vendors, research institute and university, and other organizations like EPRI. This working group is actually an expert pool available for all IAEA activities on the different topics. So, and the terms of reference for the different working groups are inherited from the ISOP network. So why did we create a working group? Because all those innovative digital technologies change fast. So we have to adapt to the evolution speed of all those new technologies. So we believe that a working group will help us to address faster the different issue and maybe let's say accelerate the different activities that we can implement to support the different member states. So it helps us to increase the collaboration internally and externally. And also, I would like to mention that this group is inclusive. So in nuclear energy, and especially in my section, we focus on operating countries. But for those working group, we welcome all the knowledgeable stakeholders, but we want these groups to be active. So we want to have members who can contribute in one way or another. And what we are doing also is we organize quarterly calls with the working group members in order to update them on the different activities and also give them an opportunity to talk about their activities and make the promotion, for example, of the different events the company, their organization are planning. So it is a good way for the networking, because sometimes for some project, it's difficult to identify the right person. And also it helps the member states to be aware of what we are doing. So for example, if I organize something on AI and then my colleagues from the safety assessment sections organize another events. And for the member states, it's easier to really target the events you would like to attend. So as an example of the output, 3 weeks ago, I would say, I organized a technical meeting on AI and its near term deployment in operating nuclear power plants. So it was a big technical meeting because I received around 90 nominations. The room was too small, so I had to accept only virtual participation after a certain time. And then in parallel, this working group is supporting me in the drafting of a new publication on the deployment of artificial intelligence in nuclear power plants. And for example, from this working group, we defined 2 roles. We selected volunteers for forming the editorial board, and another group we call the review board to help us with that. So regarding AI, we are currently working mainly on those 5 aspects. So the opportunity for nuclear power plants, the AI lifecycle management, the regulatory consideration. So I want to mention that even if I covered it partly, my colleagues from safety assessment are the leaders regarding this topic. And then also, when we talk about digital technologies, AI data management is a very important aspect, and it's important to identify the different issues related to data management. And also, nuclear industry always comes after I mean, we are often late compared to other industries. So we wanted to leverage from other industries. And for example, during this technical meeting, the Food and Drug Administration of the USA made a presentation on their regulatory framework. So in the working group, as I said, we are sharing a lot of information about the different activities to help target better. And well, we have in the plans, so we are scheduling a new technical meeting on the safety implication of the use of intelligence, the artificial intelligence. And we have implemented collaborating center in collaboration with Purdue University based on the 3 pillars indicated on this slide. So the first is modeling and simulation. The second is validating AI concept for nuclear power plants. And the last is education and training. So thank you very much for your attention. So
thank you, Nelly, very much. For the persons that have questions to Nelly, please feel free to put in the chat. We are going to move to the next presentation, but we come back to all the speakers for the Q&A. So to continue the discussion on the implementation of disruptive technologies in nuclear, we are going to go to Berenger. Berenger is the Chief Data and Digital Officer of Tecnatom, where he leads several teams related to AI, machine learning, software factories, startups, and so on. He has more than 20 years of experience in several global companies with a professional career focused on data, digital, and innovation. He's part of the IAEA Chairing Committee of AI technical meetings that Nelly presented. And he has an MBA and OIT degree in artificial intelligence and data governance. Berenger, thank you very much for accepting our invitation. The floor is yours.
Thank you, Alice, for this introduction. And good to see you, Nelly. I'm glad to see that we have the usual suspect here in all the events. So let me share my screen. Do you see the presentation?
Yes.
Yes. All right, so the challenge is not talking about generative AI. The challenge would be to talk about generative AI in only 10 or 12 minutes. So we will try to go straight to the point, not to go too much in detail, but feel free after that. If you have some question, I will be pleased to answer that. So first thing, when we talk about generative AI, what it is, I think a fairly short definition of this concept could be that algorithm that create new unstructured content. They are typically related with unstructured content, as we will see, like images. This is the most salient example that we have, but they can do a lot of things. I think you have all heard about ChatGPT. I think since starting of this year, it has been a real hype. Everybody was talking about it, and indeed, it's absolutely amazing. I think it also have a massive adoption. This is why it makes it so revolutionary. But we are just scratching the surface when we talk about generative AI. I think this is a good ambassador to talk about that kind of concept, but the revolution behind that is much bigger. To give you just a brief view of this landscape, and this actually 3 months ago, I found this picture, but I guess now it would be obsolete because it's changing very fast. But at least you have the main categories that are considered under generative AI. You can have text generation, like we have with ChatGPT, video, images, code, speech, 3Ds, and other things. So you can have plenty of possible output of that. And this is why it makes it so bigger, so revolutionary, because it's not only a text with ChatGPT, but I'm sure you have tried with DALL-E, with Stable Diffusion, with Midjourney for images, for instance, which is certainly amazing. And also how to automate videos, for instance. You can copy paste a text and it automatically produces a video or presentation with Storm AI. I guess you have tried it or for code, as we will see a bit after. So this is absolutely amazing what it can do. Just a brief differentiation, why we call it generative AI and not AI as itself. Indeed, we have a traditional AI, traditional model perform a function based on input that we know and output that we know. For instance, if we want to train an AI for inspection of baffle balls, then input data will be baffle balls inspection and C-scan, A-scan, and so on, and the output will be also related with baffle balls prediction. So we know the input, we know what we put in the model, what we want to be trained on, and we know what we expect to have somehow. So the input and the output data maintain also modality. It's the same thing. If I put a text, I get a text. If I put an image, I get an image. If generally, we have the same modality within traditional AI. It's true that we have some exception, but we maintain the same modality. And also, it's aimed to find a specific pattern or to solve a specific task, generally classification, recognition, regression, or prediction of something. Right? When we talked about generative, it's a bit different because we know the input, but the output is usually unknown. So this is why it's so new for us. Right? It creates something that was not specifically trained to do for. Also, it can switch modality. It can be multimodal. You can have, for instance, an input in text and you get an images, an input in text and you get a video, an input an image and you get an audio. So this is also very surprising. It's brand new concept. Yes. So why this is such a revolution? This technology, and I just put you some example, but I think it will reshape our society and our industry. It's something that will be applied massively. We have a massive adoption. So this is not only for our company, our industry, this is talking, considering our society. It's something that also would provide a new way to interact with information. We will see, for instance, ChatGPT, but other things, how easy it is to find the information, to interact with the information. It's like having a brilliant peer and who can ask everything we want, and we have someone that is able to provide us information in a fairly short amount of time. To do comparison also, please compare this and this, and he provides us a table. So yeah, it's amazing. Time saving also increase our productivity with a great time saving, and it will improve significantly our knowledge and performance. I'm not expert in nuclear safety, but I'm sure if I ask that kind of model, what is a nuclear safety regulation? I can have at a glance an overview of that. What are the main challenges of nuclear safety? And I can get some. Give me some example of a past incident that have impacted nuclear safety, and I can get it. So even if you are not expert in something, it will provide you fastly a knowledge, and it will improve your performance. And so it will be surprising because it will spark our initiative and creativity. So far, creativity has been reserved for the human, but it seems that those generative AI are also entering in that kind of holy space, which is reserved to the human, and creativity is pretty amazing with those tools. So just in short, it will open us a new era. This is something that have been before and after. So you have a new era behind us. And it's a change of paradigm, the way we will work, the way we will interact with information and AI. And just because it's a massive adoption in diverse tasks. So basically it's for everyone and for every day. And this is why it's such a revolution in this case, because it will apply for a large amount of people and for a large amount of tasks. So here I just put you a generic scheme, but I think it's easy to understand. We always have the same scheme. We have a prompt, we have an input that goes to a model, and it will give you an output, right? So your prompt generally is a text so far. When we talk about generative AI, it could be in voice, it could be images, but let's think that they generate text input. And then here you have a model. The model could be a text model, image model, code model, whatever you want. Basically, here it has been trained on a large corpus of text in the case of ChatGPT, a large corpus of images for Stable Diffusion DALL-E, or a large corpus of code, as we have seen with GitHub Copilot, for instance, right? So when you ask something to this model, which is trained on a large corpus of text, images, or code, it will provide you this output. So if you ask him for an answer, it will give you a text. If you ask him for an images, he will produce an images. If you ask him for a code in Python or whatever, he will give you this, right? So it's always work like this. You have then maybe heard about prompt engineering. You have two kinds of prompt engineering. The user prompt engineering, as we say here, the answer you get here depends on the question you ask. So make sure your prompt is well settled, well calibrated, so that the model will understand you better. And also we, as technical people, who can work on system prompt engineering. So that means that we can not fine tune, but to put something in his memory so that you don't have to write every time in your prompt that kind of stuff. You can integrate some kind of system prompt here within the model. So some example, I think you have all seen this kind of image generation based on a text. I want a unicorn riding in a desert, and it can provide it to you. So it's very amazing, the creativity and the quality behind that. You can have photorealistic, you can have images, you can have that kind of artistic representation. This is absolutely amazing and unexpected somehow, because we really don't think thought a year or 2 years ago that AI could be so fast, be creative. And we can also have AI-based content creation with virtual assistants, for instance. I give you two examples that we have here in Tecnatom. We use that kind of virtual avatars. So we have that kind of virtual avatar to ease content creation for learning. For instance, we use a deepfake here, for instance, with that kind of just one photo. You can animate this photo.
I'm Beren, not the real Beren,
and
but
put your
virtual
voice
one
on
that we
that.
have created for you to see this technology. We could, for instance, have
with my accent and so on. So you can see that AI-based content creation is booming as well. And just with one picture of an instructor, we can have this instructor virtualized, and then we can just add some text, his voice, and so on. So it will ease content creation, in this case for training and learning in nuclear. It will also enhance activities and user experience. It will improve results and also ensure cost efficiency for all content creation and training and learning activities. Some use case also that we have seen is using GPT. ChatGPT is one of the fine-tuned model of the GPT families. So I'm sure you have all tried this by yourself with daily tasks. You can simplify complex topics. You can ask to summarize an article or a report. You can do a brainstorm with him to benchmark or compare something in a table to analyze information and so on. So you can do plenty of daily tasks using GPT. We also use some specific use cases we will see after in a model that we train, and not using ChatGPT, of course, but we use it for learning. We can have course summary, course overview, so that also we can copy paste that kind of summary and have automated content creation that we have seen before with a virtual instructor, for instance, or creating a video so that we can have introduction for each course very easily. We can create ad hoc exam. This is very time-saving for us because we have, I think, 150 instructors, and each of them have to produce exam. So it's quite a lot of time for them to produce new question and answer. So now we are using that kind of tool to create some question and answer, multiple choice, for instance, true, false, or fill the blank question, to create some of that kind of ad hoc exam. We can promote adaptive learning, ease content creation, promote micro-learning, and so on. So we can do a lot of things to ease learning as well. And for coding, this is absolutely amazing because it not only speaks English, Spanish, or French, or whatever, it also speaks Python, it speaks JavaScript, and so on. So we can create code, we can explain the code, we can simplify code, translate code from Python to Java, we can write down documentation, track down bugs and fix bugs, we can do code refactorization, unit tests, and so on. So this is absolutely amazing tool for us as well to generate code and to ease development and coding in general. So we create GP Tech for Tecnatom, so a GPT in Tecnatom is GP Tech, to ensure a safe and responsible use of this kind of technology. Because I think this is the key message behind this presentation. Generative AI is great, but we must ensure a safe adoption and responsible use of those technologies. We are in a nuclear industry, very regulated industry with high impact. So it's true that it opens a lot of opportunity, but we must be very responsible and ensuring that it's safe. So this is how it works. When you do your question and you get your answer, first you upload your document, so it's all vectorized here. So it translates the text into vectors, into numbers. When we have that knowledge base vectorized, then we can recreate it within a conversational form with our OpenAI Microsoft services, and we get an answer. So this is what we do. We do a user portal, which is very similar to ChatGPT, but ChatGPT, it's a public access model with public data, so it will be on one, right? So it's not so great for daily thing with your kids and so on, it's fine, but for nuclear industry, it's not so good. Obviously, in that kind of case, when you put proprietary data or nuclear data in a public access model, this is why we absolutely need to avoid that kind of thing. And we are here on the diagonal here. So we have a proprietary access with specific nuclear data for instance. It's true that, for instance, we can also use public data here. I use, for instance, IAEA report, and to get a summary, for instance, I use the document that Nelly sent us for the technical meeting, and it gives me a fairly short summary of this document. So we can also use public data here. But what we have created is to ensure a safe and responsible use of generative AI for text, in this case, a ChatGPT-like if you want, but for nuclear, for Tecnatom and Westinghouse. Right? So we access it with Azure Active Directory. So we work with IT to build a secure access. We work with legal to produce a user agreement to translate part of the responsibility to the user. And also, we do work with the two teams that I lead, Data Lab for data management and AI, and Software Factory for solution development, to build that kind of safe interface when user can have interaction with GPT. Right? And we are also monitoring logs and so on. Some consideration, export control information. I'm sure you know it about in the nuclear industries that we are. Export control is still an issue sometimes because we have an instance in Holland. It's not in Spain. So we have to make sure and user responsibility is engaged in that case. Copy-paste is not recommended. Also, if you do copy-paste in the tools that we have, you will have a pop-up that appears. Please read it twice. It has been generated by AI. It's not, it could be coherent, but maybe not relevant. So copy-paste is not recommended. Be aware of that. It's an experimental phase so far. We have continuous subject matter expert review. We have now 3 months time running with this solution. And we have, I think, a group of 30 people constantly reviewing the outputs that we get for learning, for operation, for inspection, and so on. Also, for those of you that are not technical, we are talking about stochastic model. We have 2 kinds of model, deterministic or stochastic. Deterministic is fairly easy to know what would be the output, because if you execute 100 times the same thing, you would surely get 100 times the same output of that. Right? It's deterministic. We know what will happen somehow. But stochastic, yeah, you can execute the same prompt and you will get different outputs. So this is quite disturbing somehow, because there is no official response in this case. So you will have different output each time. And also typical issue that we have with all generative AI, how we will manage intellectual property, for instance, an image, whose property is that, the text, if we are promote a wrong text into a manual, for instance, whose responsibility is this, and so on. And just to finish on that, I'm not sure if I have a lot of time still, just to give you an outline of what we can do with that kind of tool, GPTech. So you can summarize documentation, as we see with the one of Nelly, the IAEA. You can produce ad hoc exam using different kind of questions, multiple choice, true, false, fill the blanks, and it's worked quite well. GPTech also can produce new knowledge, new insight, which are not explicitly presented in the documentation. So this is very great to have that kind of generative AI, because, for instance, here I give him a large 300-page document of hydrogen, and there is no paragraph, there is no specific section talking about key challenges of hydrogen. But he reads the document, he understands it, and provides me a new output related to that. Also, what is the relationship between alternators, for instance, and speed? Well, he understands both concepts and he can relate to. Or just provide you the specific information you need. You can spot the exact information you want to see. Also, it's interesting, GPT-like feature as well, to have that kind of level of conversation. So it can adapt to your needs. Explain it to me as if I was a 5-year-old child, for instance, or I'm an expert, go on and give me a lot of details. So you can have that kind of different level of interaction as well. Also, this is multi-language interaction. So this is absolutely understanding, because you can upload a document in English, for instance, and you can interact with the document in Spanish, in French. So for him, the language of the documentation is not relevant, because it will vectorize it. If you remind, it will convert text into numbers. So then you can interact freely in several languages. For us in a global company, this is very useful to have that kind of possibilities. Also, just want to conclude on that, our solution, in this case, our generative AI in Tecnatom, focuses on the documentation you provide. We don't want him to be too much creative or to avoid that kind of hallucination that kind of model can have. So inventing some answer, some response. For instance, I give him some documentation and I ask him, what is the capital of Spain? And he says, sorry, the given context does not provide information about the capital of Spain. And I try to do that, we all do, I guess, in ChatGPT, to push him to the limits. You know, come on, I'm sure you know it. What is the capital of Spain? No, he stick to this. Then I give him the right answer. Madrid is the capital of Spain, not you know it, really. And he said, I'm an expert in the context provided and my knowledge is limited to the information presented. The context does not provide any information about the capital of Spain. However, as a language model, AI, I do know that the capital of Spain is Madrid. So it's interesting because he acknowledged that he knows it, but he also acknowledged that with the system prompt engineering that we have done before, and we ask him not to be creative. If it's not in the documentation, please do not answer. So he stick to that. And so even if he says that he knows that, I ask him again, so can you tell me what is the capital of Spain? And again, I'm sorry, the context provided does not include information about the capital of Spain. So this is great. That was our major preoccupation, to have that kind of generative AI applied in nuclear industry. and give us some hallucination of some invented response. But as you can see, it is very well limited. For example of text that we have done in ChatGPT in this moment, from Python, from JavaScript, from Excel and macro, so it works, and you can copy paste the code, and it's totally functional. It's great. And just to conclude, here in Tecnatom and Westinghouse as well, with my colleague now, you know that we will be one company soon. We have a three-step approach to ensure a safe and responsible use of generative AI. First is obviously education. We need to educate our employee, our colleagues to these new technologies. We are all passionate about that. We are all willing and very excited to use it, but we need to understand the concept, the value, and also obviously the risk that are behind this. Do not copy paste everything without reading twice, and that kind of thing, right? Then we are also doing quite extensive exploratory phase with all the areas, not only the business line, but also corporate area, to define features and also to consider use case. In line with IT and legal, this is something that we need to build between legal consideration as well and IT focus as well. And then implementation, what we recommend is to add value with minimum viable product. Don't think too big because it's moving fast, the technology is changing fast. So it's not worth to invest 1 million in one case, maybe next year, probably it will be obsolete and we have something new. So just do some small steps, sure steps, adding value for your business line, for your corporate line, because people are willing to use it, users are asking for it. But don't get too crazy with that. Technology is evolving fast again, so just play with the technologies that we have now, ensure safe and responsible use of that, and let's see in the future what will we have.
Thank you, Berenger. Thank you very much for the presentation. Generative AI is definitely something that we think about a lot with ChatGPT and everything. So yeah, please, I see some questions in the chat. Continue putting questions in the chat. For the next presentation, our speaker is going to bring a different example of technology. Cristina Corrales, she's the principal technical lead in the Instrumentation and Control program of the nuclear sector at EPRI. She's currently focused on her research on digital twins, human factors engineering, and INC systems operating experience. She's also responsible for conducting and managing other research activities associated with online monitoring and the digital systems engineering framework. So thank you very much, Cristina, for being with us today.
Thanks to you, Alice, and well, hello to Beren and Nelly. It's good to see you again. As we say, the usual suspects, as Beren said, and thank you everyone for joining this event. I'm excited to see so many participants. So just let me check, are you seeing my screen, a PowerPoint that says EPRI examples on digital twin research?
Yes.
Okay, good. So let me start with my presentation by talking a little bit. I wasn't sure how much the attendees will be familiar with EPRI, so I wanted to let you know a little bit what EPRI is. So in 1965, there was a blackout, a big blackout in the northeast of United States, and that was what promoted the creation of EPRI, which is a non-profit energy research institute that was founded in 1972. Our model is collaborative. We collaborate with more than 450 companies in 45 countries. And our motto is, together we are shaping the future of energy. Some of the key aspects of EPRI is that we are a non-profit, we serve for the public benefit. We try to systematically and imaginatively look ahead and identify issues and technology gaps. We are independent. Our research is what drives our comments and our input to the industry. We provide expertise in technical disciplines to the electricity generation, transmission, distribution, and end use of energy. And one of the most important things that we do is that we bring together our members and diverse scientific and technical sectors to shape and drive the research. So collaboration is one thing we really take into account and that we really try to provide benefit to the industry with. Assuming there is a lot of young people, you have here, we are present on online media, so you can check us out if you don't know about us. And me particularly, as I said, well, I don't think I said this, but in EPRI there are 4 sectors of research. One is nuclear, one is conventional generation, the power distribution and utilization sector, and then there is another one dedicated to low carbon resources. So I work within the nuclear sector in instrumentation and control program, as Nelly said, and you have a little bit here of our mission in case you are interested. So going straight to the topic, I will talk a little bit about the digital twin, and I'm not sure if you all know what a digital twin is. The truth is that definition, a consensus definition is not yet there. There are many definitions that share a lot of aspects. We will talk about that. The concept was originated in 2002 by Dr. Michael Greaves, a professor in the University of Michigan, when he was talking about the product life cycle management, and he talked about the real space and a virtual space that share data, being that the real space informs the virtual space, and the virtual space provides information to make decisions in the real world. Okay. So that was 20 years ago. At first, he didn't really talk about digital twin. He didn't name this concept as digital twin, but a few years after, the word digital twin was applied to this concept. But since then, since 2002, when the concept was first originated, 20 years have passed. And even though in the nuclear industry, we are well versed in the use of modeling and simulation, which are key elements for digital twins, there is not yet a successful, cost-effective implementation of digital twins in general, let's say. There are examples, to a certain level we have digital twins, but it's not something that really is prevalent in the industry. The manufacturing industry is probably more advanced than the process industries in the adoption of digital twins. They already have standards that tell them how to do them and manage their life cycles, but not so the process industries, and not so much the nuclear as well. So what is the definition that we are working with for digital twin right now at EPRI? We are talking about a virtual representation of an item that provides information to enable strategic or tactical decisions. And that is the most wide definition of digital twin. Everybody seems to agree more or less on these words. At EPRI, we are focusing on digital twins that imitate the behavior of the item, are informed by the item that we are twinning, evolve with the data from the real asset. So there are 4 characteristics that we are really trying to put together in the digital twins that we see will be useful for the industry, for the nuclear industry. They have to have models that describe the item. Those models, some of them need to be dynamic. So it's not only that we are describing what we are twinning, but we are also reproducing its behavior. So my digital twin should be able to imitate what my real asset is going to do. They should be informed by the asset. So if the plant is in certain operating condition, the digital twin should be able to see the data and synchronize itself with that operational condition. And then the digital twin should be able to evolve. So the models that compose the digital twin should detect changes and modify and be able to modify with those or evolve with those changes. We think the industry needs a little bit of talking about digital twins. And when somebody approaches me and says, hey, I have a digital twin, it's like me going to the dentist and telling him my arm hurts. Digital twin is a very wide concept, and sometimes it's difficult to understand what somebody's talking about when they talk about digital twins. So we think a classification system or taxonomy is needed for digital twins. And to do that, we have focused on three concepts, which are the physical scope. So what are you talking about? Are you talking about the digital twin of a valve, or are you talking about the digital twin of the plant? We are also focusing on the analytics category, and we will see a little bit about the analytics categories in the next few slides. And then we want to understand, in order to know what you are talking about, which use case are you applying to the digital twin. And with that classification system that we are developing, we are hoping to provide the tools to the industry to be able to think, okay, I want to develop a digital twin that does this and that, and then I need this tool, this other tool. We are not going to provide the tools to build digital twins. There are plenty in the world. We are going to allow the industry we are trying to help the industry to build them more effectively. So that's our approach. So let's talk a little bit about the classification of digital twins. As I said before, we are focusing on different aspects. On the vertical axis, you will see the physical scope, and I'm giving you some examples, the component digital twin, but there are plant system digital twins. There could be maybe functional relationship sets. So it's not we are doing the digital twin of a system, but maybe a cubicle with some valves of different systems, and that I require somebody to go in and see what is happening. We will see an example of that. And then plant level digital twins, or even we are thinking about bigger than plant level, like if you follow the news in nuclear, there is a lot of talk and projects related to coupling a nuclear power plant with a hydrogen producing facility, or maybe a paper mill. So how these two installations interact together maybe can be better monitored with a digital twin of both things. And then in the analytic categories, we are seeing digital twins that can be descriptive, they can be analytic, they can predict, or they can be prescriptive. So at EPRI, we have had in the past projects exploring some of these digital twins, and we want to continue doing so. So the descriptive digital twin basically is a virtual entity that integrates asset information. It can be design documents, inspection information, test information, work orders, the items configuration with 3D models. And the plants, not all of them obviously, but to some extent are already building these digital twins. And you have an example of one of these digital twins here in this image for a PWR. In the analytics category, this digital twin, the models incorporate dynamic models, and they reproduce behavior, as I said before. So EPRI has had a project that we will talk a little bit about, experimenting with dynamic models that reproduce the radiation fields, and I'll show you how we have used that. And then in the predictive side and in the prescriptive side, this is the research that we have now going on, okay? So this is a little bit of the status in the industry and at EPRI. So here you have a little bit of the description of a descriptive plant level digital twin. We did research on this. One of the key factors to be able to effectively manage a descriptive plant level digital twin is to have a data-centric configuration model. So when you try to put all the information about your plant and your assets in a digital twin, you need to have a model that is not document-based, but data-centric. Typically, the plants will do a 3D model of the plant. Most of the times, they just scan the plant with a LiDAR. And they use this for many applications. They are able with the 3D scan to measure dimensions, so they can check for interferences when they are trying to move equipment, if they are doing a plant modification. They also use this for training and familiarization processes and they are able to navigate this 3D model and see which are the routes where I have this component, which doors do I need access to. And then a lot of the plants are adding access points in this 3D model for information. So they are able to see in that particular 3D model a valve, and they can click on the valve and see design documents, inspection records, maybe the flow that is going through the valve, if there is an instrument that is measuring the flow through the valve. So that is fairly common and also implemented in the nuclear power plants. This is an EPRI research project, and you can go into our website and look for this number here, and you will find, I think this one is a free results project, so you will see the documentation of this project. It includes a short video. We did a 3D scan of a cubicle. We model the radiation source and the radiation field in that cubicle just by checking the radiation measurements through the cubicle. And we modeled there was a radiation source, so we put up the word is not going to come, but the shield, we put a shield, so the radiation was attenuated, and we sent a worker. This was all a simulation, not really done at a cubicle in the plant. We sent a worker to conduct some job here in a valve, and to do that, he drained these tanks here, exposing another radiation source. So the radiation field changed, and with our models, we were able to add new shielding or to fill up the tanks to see the effects it will have in the radiation field and eventually in the worker that was going to work in there. So it was an interesting project that we are continuing with a new project and now to incorporate live radiation data. So in the instrumentation and control program, what are we working with on digital twin? Because our work focuses on information technology and operational technology and traffic of data and cybersecurity considerations. We are working in these two levels that I already talked about when we saw the definition of digital twin. We want digital twins that are informed by the asset conditions, so that my digital twin synchronizes with the status of the asset that I'm trying to replicate and that evolve with the asset. And we want to see how to do this. And we haven't seen so far in nuclear examples of this being done in an automatic way. So we want to understand what are the challenges, how we could do that, if we could, and which are the precautions we should take. Excuse me. So this is we have an installation in our offices in Charlotte, in our lab, where we have a small, let's say a small plant. It's not really a reactor, it's a flow loop. And we are doing a digital twin with it. Oh, I'm seeing, Alice, you want me to speed up? So, sure, you have here the information that streams between the two assets and how we expect our digital twin to behave. Basically, when there is a discrepancy, we are hoping we will be able to either analyze the discrepancy and adjust our models in an automatic way or alert and act. This is the research that will come up. There will be a report and we will have a demo platform for digital twin concepts. And I wanted to include, this concludes my presentation, notes on previous research and the active digital twin projects that we have at EPRI. So this is it.
Thank you very much, Cristina. It's very interesting, everything, and I appreciate all the three speakers for sharing a bit today. I will go to the Q&A sessions. We have a few questions here. Let me see here for Nelly. There is a question from Natasha. Given the sensitivity of nuclear information, how will it be protected once artificial intelligence is fully implemented? And just a comment by Professor Akira is also asking if you could share the lead point of contact at the Purdue Collaboration Center.
Okay, good. So regarding the data management and security, so we discussed it during the technical meeting, and our working group is also trying to identify the different issues and maybe propose something to implement. So the issue related to data is coming also from the fact that we have different sources of data or when we are implementing an AI solution. And it is important to ensure the integrity of all those data, and also to ensure that, let's say, a good way for the data sharing among the different organizations involved in this collaboration. So we have identified several challenges in our working group. So it is related to data governance, so data sharing, data privacy, and also I'm sorry. So I was reading because I have my technical meeting report here. So we had a big session focusing on those different issues. So we are aware we do not have yet any solution to propose, but it is one of the aspects we are intending to cover in the publication we are working on now. So, and regarding the Purdue University, so I have several contacts here at the IAEA for the different activities I mentioned during my presentation. So I have the contact of at the level of the innovation network, and then the people here at the IAEA responsible for the collaborating centers, the leader for the safety assessment aspect, and also the leader for the computer security activities. So I can share those contacts, but I don't know how to proceed.
No, that's okay. If that's okay with you and with you, Professor Akira, we can put you two in touch and you can share the information after. Okay. So moving forward with the next question to Berenger, Stephanie Biala asked, are there already approaches to include also some content information? Who is asking in which environment?
Yes. Just to go back 1 second on the last question, we ensure nuclear information with dedicated instances in Azure, in this case, with isolated copy of the model. So nothing goes out, just to be sure of what we have seen, that it's totally safe. Regarding this question, it's about the system prompt engineering that we mentioned before. We don't enter so far in fine-tuning, but we can definitely include some context. For instance, yeah, we do have a connection with Azure Active Directory. So when someone connects, we know that it's Alice or Berenger, for instance. And if someone asks, give me the result of my team from Alice and my team from Berenger, we know the relation. So yeah, we can add some context within the prompt to get a more specific answer based on that. Yeah.
Perfect. Thank you. So for Cristina, we have a couple questions from Professor Akira. How do you address the fact that with digital twins, the entire nuclear industry will not have access to a given tool? There will be inequity in access of tools. Can this be resolved? And a second question is, how soon will the nuclear reactors address digital twins? Is that being done already? You are muted, Cristina.
Yeah. Thank you to Kuhire-san. Very good questions. Well, about the digital twins and the access to tools, our position so far is that we are starting to build our digital twins experiments with simulation and modeling tools that are already accessible to the plants. We are currently, most of the plants in the world have a full scope simulator, so we are using the simulation tools, the model builders, and incorporating some database models that can be created. There is obviously, depending on the, I guess, the resources the plant have, the access or the easiness to create a digital twin or to develop a digital twin, it will be there. But we are trying not to focus on any specific technology and being as wide as possible with our research, or as open-minded as possible, and technology agnostic, which is one of our drivers at EPRI. How soon will the nuclear regulators address digital twins? And if it has been done already, yes, there was a task force promoted by the NRC. I think it started back in 2000, probably 19 or 18. They have a couple of public reports that I can share. So definitely the NRC and other regulators are looking into digital twins as part of the tools that will be used not only to monitor operating reactors, but to build the new ones and to validate the designs and things like that. So yes, I guess the answer is being done already. Is there any active digital twin being evaluated by the regulators? I don't think so. So far, they've been used in non-safety applications. And how will EPRI integrate non-digital operations data that will be missed by a retired nuclear worker? If I knew that, I think they will give me a Nobel Award. The loss of knowledge is something that has everybody in this industry very concerned. And we need to, I mean, there are ways to capture that, but we are not focusing our research yet on that. I think there is another observation on the National Cooperative for this a contract in Switzerland, and I appreciate Stephanie sharing that. I will pass that information. I was personally not aware, but our radiation protection and waste management research team has also digital twin active projects, so I will pass that information.
Thank you very much, Cristina. Nelly, another question to you from Erica. With the rapid development of many different types of AI, in your opinion, how important will regulation of artificial intelligence technology be?
I think it's a very good question because up to now, it looks like we do not have yet any regulation for AI, and most of the applications are related to non-safety applications. So as soon as we will start considering safety-related or safety applications, we will have those applications will have to be strictly ruled by standards. So my colleague from the safety assessment section is actually taking a deeper dive in the existing standards and IAEA documents in order to see what should be started, what should be implemented. So we organized this first technical meeting in May to have a good idea of what is available now in the nuclear industry, because we are talking a lot of about AI applications, but we needed to know what exists in the different member states and what is the level of maturity, because my activities focus on the deployment or near-term deployment. But then also my colleagues from the different, let's say, complementary activities. So it's computer security and safety assessment also were wondering about what we should do. And what is really important in what we are trying to do now is we are trying to engage the stakeholders as early as possible. So in the working group, we have regulators, we have utilities, we have vendors and research institutes in order to try to align the expectations of all those stakeholders and try to save time when possible. I was positively surprised with the level of engagement of different regulators because I counted during the technical meeting, I had 1, 2, 3, 4, 5, 6, 7, 8 regulators, which is a lot for technology not yet implemented in existing, I would rephrase, not yet implemented in safety systems in existing power plants.
Thank you very much, Nelly.
You're welcome.
And to finalize this part, the last question to Berenger. Berenger, from Josh, have you experimented with local models for clients who would prefer not to have their information uploaded to the cloud?
Yeah, this is a recurring question about a cloud or on-premise. Yeah, we still have the same problem. If you use GPT, you have to be cloud because GPT is within Azure OpenAI services, so you cannot have it on-premises. But you have also some alternative, open source alternative, for instance, Bloom, which is similar to GPT-3 in terms of a large language model. It's less than 1 tera, so it's a big model, but you can also install it in your machine. So if you want to experiment locally on premises without cloud, you can have some that kind of open source solution alternative. If you want GPT, it must be cloud so far.
Okay. So we're finalizing this portion, this first part of the session. I want to thank again Nelly, Berenger, and Cristina for your participation and your insights. We hope to count with you again in other opportunities. Thank you very much.